$489 billion. It's a truly staggering amount of corporate debt.
Oh, yeah. It's astronomical.
I mean, we're only halfway through the year, 2026. Yet these tech giants are borrowing money like absolute crazy. They're literally mortgaging today to build our tomorrow.
Mm-hmm.
Like they just want to force this AI future into existence.
Yeah, they really are. It's an unprecedented level of financial leverage. Just wild.
Welcome to the deep dive. We're really thrilled you're joining us today.
Definitely.
We've got a massive stack of tech updates to unpack for you. We're going to start with that $500 billion corporate debt.
Right.
Then we'll trace how that money actually becomes physical infrastructure. You know, we're talking gigawatt scale data centers built across the country.
The physical footprint is just massive now.
It really is. Next, we'll explore the wild new software layer emerging. We'll look at tools directing movies, writing code. And finally, we will unpack a massive breakthrough in AI cybersecurity.
Which, honestly, that cybersecurity development, it kind of changes the entire tech ecosystem completely.
Let's start with this massive financial gamble. I keep seeing these unprecedented borrowing numbers flash on the financial terminals.
Yeah, it's hard to miss.
Can you break down exactly what Goldman Sachs is reporting?
Yeah, so they report $489 billion in AI debt. And that was issued in just the first half of 2026.
Wow.
I know, right? This number already crushes the entire 2025 total completely. Like last year only saw $322 billion in debt for the whole year. And about 40% of this new debt, it comes directly from the hyperscalers.
Let's quickly define that term for anyone totally new. Hyperscalers are the massive tech companies running the world's biggest cloud server.
Exactly. They're the foundational layer of the internet.
Right.
So let's look at how this breaks down among the giants.
Right.
Amazon, they raised a whopping $53 billion in debt.
Just Amazon.
Just Amazon.
Yeah.
That includes this massive $37 billion U.S. bond offering they just did. Plus, they added another $16 billion in euro-denominated bonds.
But why are they using debt instead of their cash reserves? I mean, they have so much cash.
Well, using debt allows them to preserve that actual cash perfectly.
I see.
Yeah, they keep it available for sudden, massive strategic acquisitions. Plus, the interest on corporate debt, it's entirely tax deductible.
Right. Of course.
So it's fundamentally cheaper than spending their own operational revenue.
That makes a lot of sense from a purely financial perspective. What about the other major players in this space?
Well, Alphabet issued around $20 billion in corporate bonds themselves. They're funding new data centers and, Gemini-related hardware expansion. And Meta continued their borrowing spree with a $30 billion bond offering.
Wow.
All of that tied directly to AI infrastructure projects. But honestly, Oracle seems to be the most aggressive spender right now.
Really? Oracle?
Yeah, they're really pushing the limits of their balance sheet. They raised around $25 billion for their new infrastructure.
Okay.
Their long-term debt jumped from $96 billion to $149 billion.
That is a massive jump.
A 50% increase in just one fiscal year.
I keep comparing this to building the 19th century railroad.
Oh, yeah. That's a good way to look at it.
These companies are borrowing against a distant, highly speculative future, and they're forcing that futuristic vision into existence with just brute capital. They're laying down digital tracks before the trains even exist.
That is a brilliant analogy. They know the first one to finish the tracks wins everything.
But, this raises a really serious question about corporate strategy.
Okay.
How do they balance this financial risk versus the actual technological reward?
Well, the reward is basically a decade of absolute uncontested market dominance.
Right.
If they capture the foundational AI layer, they basically print money forever.
Yeah.
But the risk, it's an unprecedented corporate default wave. If the technology stalls, they're just stuck holding empty, expensive data centers.
So it's basically total market monopoly or complete financial ruin.
Exactly. There is very little room for a middle ground here.
Yeah. And this debt isn't just numbers on a Bloomberg terminal screen.
No, not at all.
It's buying physical steel, massive plots of land, and electricity. It is flowing directly into the physical layer of our world.
The real-world footprint of this investment is, honestly, hard to comprehend.
Let's unpack the sheer scale of this physical infrastructure build-out. What exactly is OpenAI planning to spend their capital on?
So OpenAI plans to spend $750 billion on infrastructure.
Wow.
Yeah, And they intend to deploy all of that capital by 2030.
That is $750 billion on physical buildings?
Yep. Their first massive data center is currently being built in Georgia. It's this staggering $20 billion standalone server facility, and it requires 3.2 gigawatts of continuous power. Whoa! Imagine 3.2 gigawatts just to power servers.
2 sex islands.
It's unbelievable. A typical nuclear reactor produces about 1 single gigawatt. So they need 3 entire nuclear reactors just for one building.
That puts the sheer scale of this into perspective perfectly.
Mm-hmm.
It's not just data centers consuming this capital either. I saw Travis Kalanick's robotics startup, Atoms, just raised $1.7 billion.
Right, and he's the former CEO of Uber, for those keeping track.
Yeah, they got backing from Andreessen Horowitz, Uber, and Bain Capital. What exactly is Atoms trying to build with this massive funding?
They're building AI-powered machines to completely automate physical work.
Okay.
We've mostly seen AI living inside cloud servers until now. Atoms wants to give those AI models physical robotic bodies.
Wow.
This could reshape traditional industries and factory logistics from the ground up.
But if we need 3 nuclear reactors for one single building, how does our existing physical power grid handle this massive limitation?
Well, the short answer is it doesn't. The current grid simply cannot handle that level of demand.
Right.
So hyperscalers will have to fund private nuclear and geothermal plants. They are literally becoming utility companies just to fuel their own servers.
They must build entirely private, off-grid nuclear ecosystems. Beat paint. We will be right back after this quick break. Sponsor.
Welcome back to the Deep Dive. We've talked about the massive debt and the physical infrastructure.
Yeah, the heavy stuff.
Now let's look at what this actually powers for you today. Because we are seeing an absolute explosion of new software capability.
Totally. The software layer is evolving much faster than anyone originally predicted.
Let's start with developer efficiency and the new coding tools. We have a product called the Cursor Router making waves recently. Can you explain how this specific tool is changing software development?
Yeah, so Cursor Router basically acts like an incredibly smart traffic cop. It delivers frontier-level performance while cutting development costs by 60%.
60%.
Yeah, and it does this by automatically picking the best model for tasks.
Walk me through how that routing mechanism actually works mechanically. Sure. So if you ask it to fix a simple spelling error, the router sends that task to a cheap, fast AI model.
Right, you don't need a supercomputer for a typo.
Exactly. But if you ask it to rewrite an entire payment database, the router sends it to an expensive, highly advanced model. You only pay for maximum brainpower when you actually need it.
That is a huge win for software startups trying to survive right now.
Oh, absolutely.
We're also seeing wild advancements in the creative AI space. I saw Google is giving away 50 Flow credits free of charge daily.
Yeah, they are.
And we also just saw the release of Qwen Image 3.0.
Right. And Qwen is generating extremely complex, realistic details from very long prompts. It's genuinely useful for professional workflows, not just quick memes.
I must make a slightly vulnerable admission right now. I still wrestle with prompt drift myself almost every single day.
Oh, yeah. Happens to everyone.
I'll ask the AI for like a gritty cyberpunk city scene, and by the 3rd revision, it gives me a watercolor of a cat. The model just completely wanders off from my original instructions.
You are definitely not alone in feeling that intense frustration. It's so annoying.
How does a tool like Qwen actually solve this problem technically?
Well, let's quickly define prompt drift for anyone experiencing it blindly. It's when an AI forgets earlier instructions during a long conversation.
All right.
Qwen fixes this by using a much larger context window memory. It essentially keeps your first instruction permanently pinned to its working memory.
Oh, nice.
Yeah, constantly checks every new pixel against your original overarching prompt.
That makes controlling these models so much more reliable today.
Definitely.
And speaking of creative control, Elon Musk made a really fascinating claim recently.
Yeah, he did.
He says Grok Imagine will create a historically accurate movie. He specifically mentioned generating a full adaptation of Homer's Odyssey.
Which is huge.
And he claims this will happen before 2026 ends.
Generating a cohesive feature-length film is a massive technical challenge. I mean, you have to maintain character consistency across thousands of individual frames.
Yeah, it's wild. We are also seeing big upgrades in voice and user interfaces, right?
Oh, yeah. Claude Voice Mode is getting access to Opus and Sonnet models.
Mm-hmm.
Those are just different sizes of AI brains built for varying task complexities.
Right.
Plus, OpenAI Codex just added a quirky new skill called Hatch.
Hatch? What's that?
Yeah, you can use it to give your virtual pets fresh new looks.
That's hilarious. It's always funny seeing massive companies release such playful
It
features.
is kind of funny.
But we also have to talk about these serious, specialized agents. We have Humalike, giving your AI deep social intelligence for communication. We
Right.
have Buzzy acting as an AI video co-director for creators. And
Yeah.
crucially, we have a new tool called Castra entering the market.
Yeah, security tools like Castra are becoming absolutely essential right now.
Why is Castra so important for this new agent ecosystem?
Well, Castra controls exactly what your autonomous AI agents can actually do. It's designed to block dangerous prompt injections before they execute.
Let's define prompt injection simply before we go any further. They are malicious hidden commands that make AI break its own safety rules.
Exactly. So, Castra acts like a firewall between the agent and the internet. It scans incoming text for hidden commands trying to hijack your AI.
Wow.
Yeah, it prevents sensitive data leaks before they ever have a chance to happen.
With thousands of these specialized agents launching every single week, how do we actually adapt to this sheer volume of new software capabilities?
Honestly, you have to fundamentally change your entire mental model immediately.
Right.
You must stop treating these tools like advanced search engines completely. You have to start managing them like a specialized team of digital employees.
We must manage these tools like a specialized digital workforce. Beat. And that directly connects Castra's security approach to our final topic today.
It really does.
Because there's a rising need for hyper-advanced automated security across the board.
As the autonomous agents get smarter, the security securing them must evolve too.
This brings us to the most significant breakthrough in our sources today. Sakana AI just released a fascinating system called Fugu Cyber.
Oh yeah, this is huge.
They basically put an entire elite security team inside one single API.
It is a totally brilliant approach to handling complex cybersecurity threats.
So the system uses multi-agent orchestration to get the job done. Let's define multi-agent orchestration so we're all on the same page. It is a team of AI bots working together on one problem.
Right, and they each have very specific, highly specialized roles.
Let's walk through exactly how this Fugu cyber workflow operates mechanically.
Sure.
When a user sends a request, it triggers 4 different specialist agents, right? First, we have the analyzer agent step in and read the code.
The analyzer is scanning for tiny weaknesses that a single model might miss.
Then a second agent called the researcher takes over the process. What exactly is the researcher agent looking for in this workflow?
Well, it looks up the historical context of the vulnerability it found.
Okay.
It scours the internet for known exploits related to that specific weakness. It gathers all the threat intelligence needed for the next crucial step.
And this is where it gets absolutely wild to me. The third agent steps in to actively verify those potential exploits.
Yeah.
How does an AI actively verify a security exploit mechanically?
Well, the verifier agent doesn't just read the provided code passively. It actually spins up a safe, isolated testing environment instantly.
Like a sandbox?
Exactly. We call that a digital sandbox in the cybersecurity industry.
Right.
It writes custom exploit code from complete scratch, entirely on its own.
Wait, it writes its own malware to hack the sandbox?
Yes. It actively tries to hack the simulated vulnerable system.
That's insane.
I know. It proves the vulnerability is real by successfully exploiting it itself. It completely removes the guesswork by providing mathematical proof of the flaw.
That is incredible.
Oh.
And finally, a fourth agent carefully reviews all the compiled findings together.
Yeah, the whole process relies on constant verification between the different specialized models.
The performance metrics they're reporting are genuinely impressive today.
Oh, they're top tier.
Fugu Cyber is hitting an 86.9% success rate. That is specifically on the rigorous CyberGem benchmark right now?
Right, and CyberGem is a standardized digital obstacle course used to test AI hackers. Hitting nearly 87% on it is a massive technical achievement.
It's also scoring 72.1% on the CTI Realm benchmark.
CTI Realm is a test measuring how well AI handles real-world threat intelligence.
That puts its performance right alongside the most advanced frontier models out there. It's competing directly with GPT 5.5 Cyber and the Mythos preview model.
Yep.
But there are some very valid concerns about this multi-agent approach. Running 4 agents at once requires significantly more computing power.
Right.
That naturally drives up the operational costs for any company using it.
Yeah, adding more moving parts always introduces a bit more system complexity overall.
I have to push back heavily on the transparency issue here, though.
Okay, what do you mean?
If this multi-agent system operates as a giant black box, how can we possibly trust the final security conclusions it reaches? I mean, we can't easily trace the exact logic the AI agents used.
Yeah, that is the primary trade-off we are facing with these advanced systems today.
Right.
You get far superior security results by using multi-agent orchestration frameworks, but you absolutely lose the step-by-step human visibility into the process. You basically have to trust the final verification agent's output blindly.
So how do we resolve this paradox of using increasingly complex AI just to secure the underlying foundation of our complex AI systems?
Honestly, we are going to see the rise of independent AI auditor model soon.
Yeah.
Their sole purpose will be interrogating the logic of these active security agents.
We will need AI auditors constantly interrogating our security AI.
Yeah. And, if we take a step back and synthesize this entire deep dive,
Mm-hmm.
we're witnessing the rapid, relentless industrialization of artificial intelligence right now.
Truly.
It starts with $500 billion of speculative corporate debt. That immense capital flows directly into gigawatt-guzzling physical infrastructure projects.
Right.
Then it filters down into highly capable software tools for users. We have tools that can auto-route code dynamically or direct historically accurate movies.
Yeah.
And it ultimately culminates in multi-agent autonomous security teams. Teams that are actively guarding the very code this entire ecosystem is built on.
It is a truly breathtaking cycle of investment, construction, and rapid deployment.
Right.
I want to leave you with a final thought to chew on today. We have companies borrowing the GDP of a small country right now.
Literally.
They are doing this just to build the autonomous agents of tomorrow. Agents that will do the coding, the physical labor, and the complex cybersecurity. So what does actual human expertise look like at the end of this 10-year bet? Beat, thank you so much for taking this deep dive with us today. Out T-Row Music.